Hello ladies and gentlemen, I am Dr. Claudia Albers, Planet X researcher and professional physicist, and today I'd like to bring to you another one of my articles. This one is entitled Planet X Reveals the Correct Star System Formation Model. Now, the accepted view of the universe is gravity-driven, so it's not surprising that the accepted theory for star system formation is the nebula accretion model, which is of course based on gravity. Now, I do not subscribe to this view because I believe that the Planet X objects or stellar cores that have invaded the solar system have shown that we live in an electrical universe. And this model is illustrated here. It's based on gravitational collapse. And basically you start with a cloud of gas, which is mainly made up of hydrogen and helium, but it also contains small amounts of other elements such as oxygen, nitrogen, and iron. And it's supposed to be gravitationally unstable, which starts it collapsing and rotating. And this then is supposed to lead to most of the gas collapsing into a star, and with what is left of the original cloud forming a disk around the star. So the star rotates and the disk follows that rotation. And the disk is called a protoplanetary disk because it's supposed to turn into planets. But there are huge problems with this theory. For example, the collapse to form a in order for the cloud to collapse to form a star, it's not easy because the collapse, it can collapse initially, but as it rotates faster and faster, there is an outward force due to the rotation which counteracts that collapse and would cause it to stop. And for this reason, we see that Saturn still has rings, and these rings have not collapsed into Saturn, and they have not coalesced into moons. And we see Saturn here with its rings, and I believe Jupiter also has a few rings, but they're not as easy to see as Saturn's rings. And these have not formed into moons. They continue to exist in the same form. Now, for the solar system to have been formed due to gravitational collapse, we would expect the cloud of gas to have formed at the center and to rotate slower than the star at the center, because the whole system is driven by the star's rotation. But we actually find that in the solar system, most of the angular momentum due to this rotation is in the planets and not in the sun itself. Furthermore, we would expect the plane of the rotation of the planets to be the same as the plane of rotation of the star. And yet in the solar system we see that the plane of rotation of the sun is at 7 degrees to the plane of rotation of the planet. So again, there is another problem. And another extremely severe problem is that planets are supposed to coalesce when this cloud of cloud or rotating disk forms into planets through collisions. But yet collisions usually lead to further fragmentation. And we actually need an object to have a certain size in order to have enough gravitational attraction to hold on to any debris that collides with it. And that minimum radius seems to be about 1,000 kilometers. So it does not seem possible that this protoplanetary disk would coalesce into planets at all. And also, in order for a planetary system to have planets in stable orbits, you would need a restoring force, because it's easy for the planets to disturb each other's orbits. And so gravity cannot provide such a restoring force, which should lead to a chaotic system which is ever changing. And yet we do not see that with our solar system. And this means that there has to be two forces, one attractive and one repulsive, or at least some kind of restoring force that keep the planets in stable orbits. Now, most star systems in the galaxy are actually binary. And there are also plenty of triple and quadruple systems, so with 4 stars in them. And it's actually not possible for a cloud of gas to collapse to more than one point. Gravitational collapse is only towards one central point. So there is no clear explanation of why one cloud can collapse to 2, 3, or more points. It does not seem possible. And therefore, gravitational collapse cannot explain the formation of multiple star systems. Then the truth is that stellar cores, which have invaded the solar system, have shown that the sun is electrical in nature, and that the electrical interactions between astronomical objects, such as planets and stars, have to be electrical in nature as well. And this is demonstrated in several ways. And basically, one of the ways is that the sun goes partially dark at times, and which suggests that it cannot be powered by thermonuclear reactions from the core. And we see here in this image, these are SDO images in the 21.1 nanometer wavelength, and they are only 5 minutes apart from July 5th, 2017. And if we compare the two images, we can clearly see that the sun has gone dark in this region. And the fact that the sun has gone dark shows it cannot be powered by thermonuclear reactions from the core. And because if it was being powered by thermonuclear reactions, and these were giving rise to the sun's emission of light, then there would be light coming from the sun's interior all the time, and the sun could not then possibly go dark. So this shows that the sun has to be electrical in nature, and that this light is given off from the sun's outer layers, not from inside the sun. So this means that the sun has to be powered by electric potential energy, which sets up a potential difference across the sun's light emitting layers. And this electrical potential difference then ionizes the material on the outer surface of the sun until it gives off light, just like a gas in a discharge tube gives off light. But the sun's potential is so intense and so high that the material goes into arc mode, and thus there is intense heat generated, and the sun's top layers become extremely turbulent. This is why we see this plasma turbulent flow on star surfaces. And nuclear reactions are possible, but these must be assisted by the sun's electric potential energy, so that when this electric potential drops, the nuclear reactions cease as well. So the sun's electrical potential difference across its top layers, it's what gives rise to the sun giving off light because of the ionization of its plasma due to this potential difference. And thus the sun has to be electrical in nature. Now the sun can only go dark if it interacts with another object which shorts it electrically, thus decreasing the sun's surface electric potential difference. But this again indicates that the sun and the objects often found in the sun's corona, these stellar cores, have to be electrical in nature. Now some of the objects observed in the sun's corona are huge, as we can see here. This one is actually larger than the sun. The size of the sun is indicated by this white circle on the occulter, and this object actually looks slightly larger. We can see it here. We can see it's a solid object from the very clear outlines we see within this plasma coming from the sun due to the CME. Now, these objects cannot interact gravitationally with the sun. If they did, we would expect these objects either to collide with the sun or to go into very fast orbits around the sun. Yet we observe them hovering over the sun's surface and even moving away from the sun with CME plasma. And this would be impossible unless the interaction between the objects is both electrical and magnetic in nature. The magnetic interaction tends to be attractive, as described by the Z-pinch effect, which seems to lead to a much better model for star formation than the gravitational one. And the electrical interaction can, of course, be both attractive and repulsive. And the gravitational attraction, well, it can only be attractive. The gravitational interaction is only attractive. So it cannot explain why objects would move away from the sun. They must be repulsed by the sun in some way in order to move away from the sun with CME plasma. So this means that there has to be an electrical interaction. We can be both attractive and repulsive. And the only thing needed to change this interaction from attractive to repulsive is to change the polarization and the orientation of charge in the material that these interacting objects are made of. So thus an initially attractive electrical interaction can turn into a repulsive one, and thus explain how these objects can be repulsed by the sun. Now, stellar cores' presence in the solar system seem to give rise to coronal holes on the sun, which suggests that the sun and these objects connect magnetically. And this is because it has to be a magnetic connection that leads to this type of connection that we see here. And this would then lead to these objects' ability to exchange plasma with the sun. And this can be explained by these two diagrams. We see several different particle fluxes from the sun. There's the normal solar wind, the slow solar wind, and we see a particle flux along a plasma loop. And this leads to the formation of these these structures on the sun, which loop. They move outwards, but they loop back towards the sun. And then we have plasma spiraling along, and these plasma loops, and it's bright and gives off light, so we can then see these plasma loops. But the other one, the other particle flux that we have is the fast solar wind, which comes from coronal holes. And these form when the magnetic field lines at the surface of the sun open up. They become perpendicular to the surface. Then a plasma from the sun's corona spirals along these magnetic field lines, and they move at a very fast velocity away from the sun. But magnetic field lines have to form closed loops, which indicates that these magnetic field lines open up because the sun's magnetic field connects to these stellar cores. So the stellar cores' high magnetic field causes or pulls on the sun's magnetic field and causes it to open up and thus create coronal holes. And it also leads to this flux transfer, particle flux transfer between the stellar cores and the sun, because then plasma from the sun spirals along these magnetic field lines connecting the sun to the stellar core, and plasma from the stellar core spirals along the returning magnetic field lines towards the sun. Thus, the sun loses plasma to the stellar core, and the stellar core transfers its own plasma to the sun. Thus, the stellar core gains energy, and the sun loses energy with that process. Now, the first stellar core observed in the stereo B images from 2007 emitted light from its ionizing envelope, which we see here, and that's on its ionizing envelope as on the part facing away from the sun. So this side of the object is emitting light. But the object became darker as it approached the sun, which we can see in these images. As it moves towards the sun, it becomes darker and darker. and when it's over here, almost halfway to the sun, it has become completely dark. And this indicates that these objects absorb energy from the sun, and that they move from an energy emission mode to an energy absorption mode as they move towards the sun, and that the energy that they absorb is in the form of light. And of course, there is a way to convert light into electric potential energy, which is another indication that stars, these objects and the sun, they're both stars, except these are all the stars, are powered by electrical potential energy. So it seems that these objects show that we are living in an electrical universe, and that the sun and stars are electrical in nature. And then, according to the electric view of the universe, star formation starts with two electric currents flowing side by side in plasma, which seems to be everywhere in the universe. And plasma is basically ions and electrons, because of which form as a result of huge electric currents in the universe. And these electric currents would start with centers of galaxies. So each current is surrounded by a magnetic field, which is in the shape of a tube around the current. And these two currents then attract each other. This is called the Z-pinch effect. It's a Faraday's law effect. And then these currents start spiraling around each other as the magnetic fields around each of them combine and compress the plasma. And when we can see, this is illustrated here, how initially currents attract each other, move towards each other. The magnetic fields, which are indicated by these circles around each of the currents, start to combine, and they compress the material that these currents are made of. And so there is this compression and this flow of material towards the center of this current, which is called a Birkeland current. And we see these vast structures in the universe which indicate that this is actually happening. We can see the spiraling structure of plasma through space. And there are two of them, one this way and another one that way. So we can see that this is happening in the vastness of space. And this indicates that this is what causes the formation of objects like galaxies and stars in the universe. This sort of thing has a scavenging effect, and it concentrates whatever material is in the form of clouds of gas into a denser objects. And this material, it would be present in whatever region of space this current is flowing through. And then, so this concentration of this material leads to the formation of galaxies and stars. And then galaxies eject other galaxies, and stars fission into two or more stars, thus explaining why we have so many multiple star systems. And then the formation of planets and moons. A reasonable explanation is that they form inside stars, and that stars eject them in the same way that galaxies eject other galaxies. And this has been shown by Holton Harp in his book Seeing Red. And so these the flow of plasma which occurs within a Birkeland current, which is formed due to the Z-pinch effect, causes plasma to move inwards towards the center of the Birkeland current tube, which we also call a flux tube. And this flow is called Merkland convection. But the center of the tube is cooler than the outer region. So as this plasma moves inwards, it starts to recombine with electrons as it becomes cooler, and thus it becomes neutral. And when it becomes neutral, it stops flowing because it is no longer affected by the electric fields in that region of space. So it basically condenses and coalesces into a certain position. And this position is different for different elements because the different elements have different ionization energies. And ionization energy is the energy required to move a valence ion, outermost or most loosely bound electron, from a neutral atom, which then becomes an ion. And it's also the energy of the photon that's given off when this outer electron is again captured by the ion, thus making the atom neutral again. And this ionization energy is low for metals and high for noble gases, which explains why most objects, for example gas giants and most planets, have iron at the center and higher ionization materials like helium on the outside in the outer atmosphere. So this explains why also we have galaxies where the stars in the nucleus of the galaxies have higher metallic concentrations than stars that form at the outer edges of these galaxies. And other materials like oxygen and nitrogen also have higher ionization energies than iron, which is why they would be mainly in the atmosphere of planets and also would be in the outer layers of a star. So a Birkeland current gathers and concentrates whatever elements are found in its surrounding region of space. And because this ionized gas is accelerated, it leads to the emission of electromagnetic waves in different frequencies, from microwaves to X-rays. Thus, these currents form something which looks like a coaxial cable, or which transmits energy through the universe and gives rise to these different structures such as galaxies, stars, and planets. And then planets cannot form under accretion of gas because, as I've explained, there are many problems with that model, but rather they are formed within stars, and stars then eject them when they become unstable because the electric potential energy becomes too high. And this we see happening with galaxies as well, which expulse quasars, which are very strong compact sources of X-rays along their axis. And these quasars in the course of time unfurl arms and become galaxies themselves, thus explaining the long line of galaxies that can be observed throughout the universe. And here we see one of these galaxies. It's an active galaxy. It's NGC 4258. And this galaxy is ejecting material from its nucleus. And we find two concentrated sources of X-rays on the outside of the galaxies, and that seem to have been ejected with this material. And these are objects that are usually quasars, and these would in the course of time then become galaxies themselves. Thus, galaxies give birth to galaxies, and so these objects did not coalesce as slowly under the influence of gravity following a Big Bang event, which shows that the Big Bang model is false. And what actually is happening is that matter is being created, and galaxies are creating other galaxies and stars, or giving rise to other stars. So stars cannot form as a result of a gravitational collapse, and thus black holes, which take the gravitational collapse model to its extreme, cannot actually exist. In conclusion, the gravitational collapse model fails at every turn to account for what we see in the solar system, but the electric view of the universe does not have such problems, and the interaction between the sun and the stellar cores that have invaded our solar system have shown in many ways that the sun and these objects are electrical in nature, and that in fact the electrical view of the universe is the correct one. This view leads to the realization that the Big Bang model is false, and that such gravitational model constructs as black holes cannot exist. And we see here my references if you are interested. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.